Hey friends, Mr. Rogers here, and as you can see, I'm in my CAD lab, just hanging out at school because no one else can show up, so I thought I'd be here. So uh, today we're going to be going through the quiz, and the quiz we did okay on. Wasn't my favorite quiz that you ever taken in your life. Um, some of us did well, some of us didn't. To be honest with you. And so I'm hoping we can review this quiz, and the ones that did not do so well, maybe we can review some of the work today and retake the quiz later this week. And so there will be a quiz retake that's available tomorrow and Friday. Uh, I guess going into next week a little bit too, but I think we could do better. Some of us can do a lot better. So let's actually take a look at the quiz itself and go through some of the questions. So question one: why do scientists say a cell membrane is selectively permeable? In other words, what does that mean? And so selectively permeable is referring to the cell membrane's ability to let certain things in and certain things out. And the cell membrane has control over that. And certain things can't get through because of their properties. Mostly things that are large and that are polar can't get through. And things that are non-polar and really small can get through it really easily. And this ability for the cell membrane to do this is super important. We don't want anything to just get into our cell. We don't want anything to just get out of our cell. We wouldn't be able to live in that function or in that ability with that going on. So we really need to make sure that we understand what selectively permeable means, because it's kind of the crux of diffusion, osmosis, and active transport. Now, the one other thing I'll add here, we learned about with cell membranes. Cell membranes also have proteins in them that act as channels and tunnels, and that's part of selectively permeable too. If a cell has a tunnel for water to get in, well, obviously they're permeable to water. Water can get in really easily, but if the cell doesn't, then water doesn't get in, and therefore water can't go through the membrane. So every cell is a little bit different in what they let in and out. That makes sense because you want your skin cell to let in things that are different than maybe your intestines. And that makes sense. Question two: using osmosis, explain how gargling salt water helps your throat when it's sore. And so when you gargle salt water, your cells are actually swollen. The salt water is very, very hypertonic. There's a lot of solute and not a lot of water. Your cells have water in them, but not a lot of salt. So the water will leave the cells, or they'll get pulled out of the cell because it isn't a hypertonic solution. So water leaves the cell, and your cells get smaller. And when your cells get smaller, they get less swollen, and you feel better. We talked about this during one of the assignments on one of the Google Meets. So I think the notes as well. Question three: which beaker is hypotonic? Which beaker is a hypotonic solution, and water will go into the cell? So if I look here, I have 10% salt, 10% salt, 10% salt. So I'm more worried about the water here. So 90%, 90% water, 90% water. This guy on the outside, 10% salt, so it has 90% water, so it's isotonic. So that's not hypotonic. This guy's 98% water to 90% water. So the water is going to go into the cell. So that might be the answer. So probably is the answer. And then C is 70% water because of 30% salt. Water is going to leave the cell. That's hypertonic. So the answer here is beaker B. Looking at this picture here, the blue dots are water. The red balls are sugar. They cannot go through the membrane. So as you can see, these guys can't fit through the selectively permeable membrane. Only the water can get in and out. Which way is the water going to move? So water is going to move from a high concentration to a low concentration. So water is going to move from this side to this side. So it's going to move left to right. Question 5. What is diffusion? Okay, diffusion is when molecules move from a concentration, high concentration, to a low concentration. Diffusion is high to low, high to low, high to low. It's high to low. Okay. Obviously, diffusion is technically when molecules move, but that's not a good enough answer. And molecules move everywhere. They really do, kind of, but they have a pattern of moving high to low. So that's how we're going to describe it. A skunk spraying a dog and its particles moving around the surrounding area is an example of diffusion. Just like spraying Axe body spray in a hallway or whatever, or baking cookies. It's moving from a high concentration right when the skunk sprayed to a low concentration. You know that because when you're walking down the street, you might be able to start smelling the skunk. And as you move closer and closer and closer, it gets more and more and more intense because you're going from the low side where the spray is still spreading out to the high spot where it's the highest concentration. And so that's letting us be able to smell to get closer. But originally, it started from where the spray happened and it started moving outwards. What is the major difference between passive and active transport? The biggest difference, passive transport, no energy is used. Active transport, energy is used. We did a big Venn diagram on that. Active transport requires energy. Passive does not. There's other things you can put too, but the main thing, the huge thing, the biggest thing in the world, passive transport, no energy. Diffusion requires no energy. Osmosis requires no energy. Active transport with pumps and with endocytosis and exocytosis, they require energy. And last but not least, question 8. Looking at cell membrane here, you guys made drawings. Some of them were pretty good drawings. Which part of the cell is considered hydrophobic? Hydrophobic means that it is nonpolar. It is scared of water. Talked about this a couple weeks ago. Hydrophobic. What is hydrophobic? So it's something that doesn't like water. So is it the head of the phospholipid, which we know is polar from our time with the cell membrane? Is it cholesterol, which we know is a fat? The steroid, so it's a fat. Cytoskeleton filaments, that has nothing to do with anything. That was just a throw-in because it's on the actual picture. And the tails of the phospholipid. We gotta think for a second. So we said it's nonpolar. So it really becomes between cholesterol and the tails of the phospholipid. And what really makes the cell membrane nonpolar is the tails of the phospholipid. So that was the answer. So that's the quiz. If you didn't do well, obviously retake it. You can come talk to me. I'm always around. You can email me. You never bother, never at all, unless you're emailing me at like 2 a.m. Or you can just take your grade and move forward. Either way. But that's the quiz. I hope it makes more sense now. If you need any help, let me know, and I'll talk to you guys later.